Hi, I'm Dr. J, and this is a video about R. In particular, we are talking about the basic data types in R, that is, numerics, logicals, and character variables. And we're going to be talking about their dimensions, so scalars, vectors, matrices, and briefly talking about arrays. Now, this is a great video for anybody who is new to R and wants to get a handle on how R represents variables and data in sort of basic ways. It's the building blocks to more complicated concepts like lists and data frames. So let's jump in. As we talk about data types in R, R actually calls this a class. And so we will be using the class function to identify the data type of a particular data that we construct. Then we will also be talking about the dimension for an object. And dimension is a little bit weird in R because it depends on whether you're talking about a scalar or vector versus a matrix and array. If you're talking about the former, then you want to be using the length function. So here's the length function, and if we're talking about the latter, matrices or arrays, we will want to use the dim for dimension function. But you'll see me using that throughout the video today. Alright, so let's just jump in. So there are three main data types in R. They are numeric, character, and logical, or Boolean if you're coming from another language. And so here's just an example of three scalars that have these three different data types. So the first one here is an approximation to pi. So here is the first data type. It is a numeric data type, and its length is 1, and therefore it is a scalar. Now, here the second one, this, especially if you're coming from another language, might seem odd, that in R, this here, which is a whole string really, is called a character in R. So the class of that object is a character. The length of that object is 1. Okay, and so this is just the way that the nomenclature works in R. Yes, in fact, right, this is a string. It's got a bunch of variables here or characters here, the S, the T, A, T, and so forth. But in fact, in R, this is going to be called a character in terms of its data type or its class. Finally, we have logical. So here we have true and false. Maybe I should do false as well. Here we can put it in as D. There's false. So C is true, D is false. If we ask the type is going to be logical, and the length here is going to be 1. So it's a logical data type of length 1, and similarly with the false variable that I just constructed. Now, you'll see a lot of code that starts off using just capital T for true and capital F for false. I would recommend, as you're getting started out, that you actually go ahead and type out the whole word true and the whole word false. And the reason is because capital T and capital F are actually themselves just variables that are currently set to true and false, but you can reset them. So you can make T be A. And now T is no longer true, but it is A. Whereas the value is true and false, I don't actually know what's going to happen here. Let's find out. Yes, I cannot set true or false for that matter to be anything else. So your code is much safer if you go ahead and type out the words true and false rather than using the shorthand T and F. I mentioned numeric variables up here. And you might be wondering, especially if you're coming from another language, about the different types of numeric variables that typically exist in different languages. Something like a double precision versus an integer, which has ramifications for how it's stored in memory in software or programming languages like C. In R, sort of the default way to operate is that everything is numeric, everything is stored as a double precision, even when it in fact is numeric, okay? Even when it's numeric, even when it is actually an integer. That's what I meant to say. And so you can work explicitly with integers if you would like. So here's an example. We're going to go ahead and set the object E as an integer, and it's a 5. And if we ask what the class is of that object, it will tell us that it in fact is an integer and it's stored in memory as an integer. Now, I think the reason that R doesn't use integers as sort of a base representation is because whenever you're doing any kind of mathematical operation, it's going to get converted into double precision or numeric anyway. And so for the most part, we are always just using numeric or double precision quantities, even when the underlying variables are in fact integers. All right, so that's basically it for data types, right? So what do we have? We have logicals, numerics, and characters. That's what we have for data types, at least the basic data types. And again, we'll get to more complicated data types later. In the examples we've had so far, we've had all scalars. And so now we want to move on and talk about vectors, matrices, and arrays. All right, so we can construct vectors by basically just putting a bunch of scalars together. The typical way to do that is using this C function. You can think about C as meaning concatenate, but there's also a cat function that concatenates things. And so, you know, once you get into R and using it, you'll just be like, yeah, I'm using C. It's the way to construct vectors. And so here's an example. We're going to construct a vector of these numeric variables. If I ask what the data type is, I have to actually type in A, it's numeric. If I ask what the length is, it will tell me that there are 4 elements in this vector, right? 1, 2, -5, 3.6, maybe I should just type it out. 1, 2, -5, and 3.6. And you can see here when R prints this out, it includes the decimal place to make sure that they are all in terms of having the same number of places after the decimal place. The second vector here that I'm constructing breaks up the phrase that we had before. By the way, this is a course that I teach at Iowa State University and is sort of the basis for the code that I'm using here in this video. In this case, I actually have 3 different character variables. So I have stat, 587, and eng. And so if I print that out, I get them separated here by stat, 587, and eng. You can see sort of the space between these different character variables. And if I ask what the length is, it tells me it's 3. If I ask what the class is, it tells me that it's a character. All right, finally, we can construct logicals. Again, here I'm writing out the true and false. Here, C is a logical, and its length is 4. Now, I will mention that C here I've used for 2 purposes. I've used it as an object, and it's also the name really of a function that allows me to concatenate things. And you can overwrite, or it's not really overwritten because this C function still exists, as does the C object. Probably in most of my code I don't do this, right? I don't name objects the same as function names. So maybe in the future I'll try not to do that. All right, so there are other ways to construct vectors though. This is not the only way. Here is a very common method for constructing a vector using the colon. So the colon operator basically constructs a vector by doing, you know, in increments of 1 between the elements. And so in this case, we're going to construct a vector of integers from 1 up to 10. And this is probably the most common way that the colon is used, is to construct vectors of these types, and we will see why in a little bit when we go to look at how to access elements out of a vector. So here we have the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is, I didn't save it as anything, but we can take a look at its class. Ooh, it is an integer. I actually didn't remember that that was the class when you construct it using the colon. Same thing with 5, -2. Right now this is going to create that vector in the reverse direction. Just check that nothing weird happened. Okay, that's also an integer. Right, so this is a very common way to construct vectors, but it's not the only way. There's the seq function, which you can think of as short for sequence. Hopefully this code is pretty intuitive. So we want a vector that's a sequence from 2 to 5 in increments of 0.05. So there it is. And now this is the first time in my video set series here, my playlist about learning R, where we've actually had an output that has more than just this bracket 1 bracket. And you know, I'm sorry that I didn't point out that every time here we have this as the starting of the output for whatever we've typed. At this point, I was just expecting you to think about that's the output. But here now we have 1, 17, 33, 49. Okay, and so what this is doing is this is just trying to help you identify in this vector, in this case going from 2 up to 5 in increments of 0.05, what specific values for different elements in that vector are. So in particular here, the 17th element in this vector is the value 2.8. The 33rd element is the value 3.6. And so sometimes this can be helpful in identifying certain elements or where things are, right? If you're looking for the 18th element, you just have to go 17, add 1, and it's 2.85. Okay, and so when you have vectors, and you'll see in a second with matrices, it's often helpful to show you where the element is that you might be looking for instance. Now, I'm realizing that I should have done an additional use of the seek function, because oftentimes I will do something like this. So instead of specifying the increment that I want, in this case I'm going to specify the total number of elements that I use. And I often use this when constructing plots, and so we'll see that in a future video. But just so we've addressed it here, this is going to construct a vector from 2 to 5, and the total length is going to be 101. So here it is. So 191, if we add it, so 91, 2, 3, 4, 5, 6, 7, 8, 9, 100, and therefore 101. You might ask why 101 versus 100. Well, you should try it yourself first off, and second off, you just end up with more round numbers than you typically do if you use 100. I don't know what's going to happen here. Yeah, see, these are kind of ugly, right? So, all right, so that's another use case. Using the seek function to construct a vector. There's another function called rep. Rep you can think of as standing for repeat, although again there's another repeat function. And so here we're going to use two different arguments in this rep function. The first one is times and the second one is each. So basically what's going to happen here is that times takes that whole vector and repeats it a certain number of times, right? So we can see in the output that we have the vector 1, 2, 3, 4, and then again 1, 2, 3, 4. So that whole vector has been repeated 2 times. If we use each, this is going to take each element and replicate it. So here 1 is replicated 3 times, 2 is replicated 3 times, and so forth. Okay. Now you can combine these two, and I'll be honest, I never remember which way it goes. Does each happen first or do times happen first? And so, I always just try it out. So we can see here that in fact what happened is that the each happened first. So we had 1 3 times, 2 3 times, 3 3 times, 4 3 times. And then that whole vector, this new vector, is repeated 2 times. So we have it once and twice. And it doesn't matter which order you put these arguments. Right, so it's still going to be the same thing. Now, there's 2 things I wanted to demonstrate here. Is this really what I... Interesting, because I had tried this. Each doesn't work. Interesting. Okay. First off, I wanted to point out that you don't have to use numeric values here. You can use characters or logicals for that matter. And then this times argument can actually have multiple values. In this case, we have the vector 2, 3. And basically what this is going to allow you to do is if you wanted a vector where A was repeated 2 times and B was repeated 3 times, you can construct that using the times argument and the vector 2, 3. Right? So here we see we have A twice and then we have B 3 times. Okay, so that's another usage of this rep function. Alright, so that was all constructing a vector. Now let's move on to accessing vector elements. So when we want to access vector elements, we're going to use the brackets. So depending on what language you're coming from, this might be the hardest thing to get used to. I came to R, I used MATLAB and R interchangeably, and as I did, I kept confusing the two. MATLAB uses rounded parentheses, but R always uses square parentheses and saves the rounded parentheses for functions. Now, you can access an element a couple of ways of a vector. So first off, we're going to construct a vector here. I just want to show you what this looks like to start off with. So it is just values 1, 2, 3, 4, and 5. Okay, but it's the character values 1, 2, 3, 4, and 5. If you want to access certain elements, then you just put the element that you want to access within the brackets. So for instance here, this takes out the first element, which happened to be the character 1. And I do want to point out here, if you're coming from another language, that index is starting at 0, that is not how R works. So this is nothing. So we index starting at 1 in the R language. Now here's an example where we're going to use that colon function to construct a vector. So this is constructing the vector 2, 3, and 4. So this will access the elements 2, 3, and 4 out of the vector A. Now they are 2, 3, and 4. You can use the C construction, right, to access, say in this case, the third and fifth elements. There's 3 and 5. You could use the rep function. Now this is going to look at the third element, but it's going to look at it 4 times, because if you run this piece of code, right, that just is repeating 3 4 times. So it's going to get the third element 4 times. And there it is, 3, 3, 3, 3. Now sometimes you actually want to access all elements in a vector except certain elements. And if that's the case, then you just want to use negative indices. So for instance, this is going to access all of the elements except for the first that we have, 2, 3, 4, and 5. Here, this is going to access all but the second and third elements. Now I do want to point out the parentheses here, right? You construct the vector and then negate the whole vector. If you don't do that, if you forget the parentheses, it's not going to give you what you want. And in fact, in this case, it's an error. Now, using the indices themselves are not the only ways that you can access elements in a vector, but instead you can use a logical vector. Now, when you do this, the logical vector should be the same size as the original vector. So our vector A has length 5, right? And so we're going to use a logical vector of length 5. So here we go, true, true, false, false, false. That's going to access the first and second elements because those are the ones that are true. And so we get the values 1 and 2. Now, this is not so convenient when you're actually having to sort of type out each and every true and false, but it's much more common when you construct some kind of mathematical operation or some other kind of operation to construct that logical vector. So here's an example where I'm going to construct a vector. The elements are 5, 4, 3, 2, and 1. And now I'm going to take that vector. I'm going to say which elements are less than 3. Well, the elements that are less than 3 are the fourth and fifth elements because they are 1 and 2. And now if we take the vector and we take this logical vector here and access those elements, we will get returned the elements 2 and 1. All right, so that's just how you access elements in a vector. You can also modify the elements in the vector basically using the same process where you access the elements and then you assign them. So here we have accessing the second element and we are going to assign it the value 22. So just as a reminder, here's what our vector looked like before. Characters 1, 2, 3, 4, 5. And now we have here 1, 22, 3, 4, 5. We can assign multiple variables or multiple elements at the same time. One way is to assign all of them the same value, right? And so in this case, the third and fourth elements are getting assigned the value 3, 4. So there we go. If we take a look at it now, the third and fourth elements are 3, 4. Here we're going to assign the third and the fifth elements, but we are using a vector of length 2, so it's going to assign the third element to 33 and the fifth element to 55. And that's what it looks like. 33 and 55. All right, so that's essentially it for the basics of vectors, both accessing elements and assigning elements in a vector and constructing those vectors. If we move on to matrices, most of it is going to be pretty similar, but the way that we construct matrices is going to be different because they're different from vectors. So here we have 2 ways of constructing it using the cbind and rbind functions. So basically cbind means bind the columns and rbind means bind the rows. So in this case we have a vector 1, 2 and a vector 3, 4 and we're going to bind them by columns. So that means the first column is this and the second column is that. And so if we take a look, all right, so the first column was 1, 2, second column was 3, 4. Just to verify, this is class is a matrix array. You know what? That's not what I was expecting. Interesting. The class. Well, then how the heck do I get the data type? All right, well, live and learn. All right, if we try to do length though on this object, this one I know is not going to work. Oh, okay, it's going to work. The length of it is 4. Yeah, who knows what that means? If you have a matrix, what you want is dim. So there we go. The dimensions of this matrix are 2, 2. Right, just as we were expecting. Now with cbind, we can also bind the rows. This is explicitly constructed so that the two matrices are the same. Another way to construct a matrix is to use the matrix function. When you use that, you need to send in a vector and then tell the function how many rows and how many columns there are. You can tell it just one of the two and it will figure the other one out, assuming everything is kosher in terms of the dimensions or the length of this matrix, this vector, and the resulting matrix. In this case, I know that I want 2 rows and 2 columns, and I send in the elements 1 through 4. And so it does that. It constructs the same matrix we've been looking at, 1, 2, 3, and 4. Now, I'll tell you that most commonly, for some reason, when I'm constructing matrices, I actually want to construct them by row rather than by column. And so you can do that. You can specify the by row argument to be true. The default is for it to be false. And so here, if we take a look at that matrix, now it puts in the elements by the row. Now I'll tell you, for those who are interested, that it does it by default by column because R is a column major order language, and it stores, that means it stores the matrix or further arrays by column first and then by row in the case of matrix. If you want to access elements in a matrix, right, you still use the brackets. Now you just include a comma. So here's an example of a matrix that's a little bit bigger. So we have the first column is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we can access a single element just by specifying. So this is second row, third column. So that should be second row, third column. That should be 8. There it is. It's 8. You can extract multiple rows and multiple columns at a time. So this says extract rows 1 and 2 and columns 3 and 4. So that's be 1, 2, 3, 4. So it'd be 7, 8, 10, 11. There it is, 7, 8, 10, 11. Now, if you want to extract all of the rows or all of the columns, right? In this case, I'm going to extract the first 2 rows, but all of the columns, then you just need to leave it blank. You don't need anything else, just leave it blank and it will extract all of that dimension. So in this case, we have first 2 rows and all of the columns. Just like with vectors, you can do accessing all elements except for some, and you just need to use negative indices like you did before. I did this one intentionally because here we have only 3 rows, and yet I used or I negated elements 3 and 4, rows 3 and 4, and so it doesn't give you an error or anything. It just says, hey, I got rid of both those rows. One didn't exist, but who cares? Okay, so got rid of that 3rd row. Just a caveat here, definitely remember the comma, right? Sometimes in my code I do this kind of thing and I forget, to put that comma in. That's not quite clear what I wanted. In this case, it doesn't produce an error or anything like that, right? It just prints out the first 4 elements in memory, right? Which happen to be 1, 2, 3, and 4. It's probably not what you wanted. If you have a matrix, you probably wanted a comma in there and just forgot. Now, matrices have dimension, right? Have 2 dimensions. That's the way I should say it. In this case, this one had 3 rows, 4 columns. If you wanted a something with more dimensions than that, then you are working in the land of arrays. And I'm not going to say anything more about that, but if you're interested, you could take a look at the array help function. You basically have to put the data in like we do with the matrix and then specify the dimensions. I'll say in my work, I generally don't use arrays, and so I find that it's not that helpful to know. All right, now one of the caveats to using vectors, matrices, and arrays is that you cannot have different data types in a vector matrix or an array. So here's an example where I'm trying to construct a vector that has a numeric quantity and a character quantity, and what happens is that numeric quantity gets converted into a character. And you can tell because there are quotes right here. So this is no longer a numeric quantity, it's actually a character quantity, and it's the number 1 symbol. Okay. If you have logicals with numerics, then the logicals get converted to numeric. In this case, falses get turned into zeros and trues get turned into ones. This is actually kind of helpful sometimes, so just keep that in mind. If you have all 3 together, then everything gets converted to a character. Okay. Or even if you just had a logical and a character, get converted to a character. So this is sort of, a real drawback to using these vectors, matrices, or arrays. And in fact, for most data analysis, you don't use them. Okay? Instead, what you use are lists or data frames, and in particular, data frames. If you're interested in data analysis, then all of your data are going to be stored in data frames. And that will be the subject of a future video. I hope you enjoyed this video. I hope you look forward to the data frame video in the future, and there'll be a lists video, but that'll be quite a bit in the future. If you have any questions about R, I encourage you to throw in a comment down below, and hopefully I can cover it in a future video. If you like this video and look forward to videos like this, please subscribe and like this video. Hope you have a good one.